Hello everyone, and warmly welcome to the launch of the Consumption Compass version number 2. We are very proud and excited to show to you today the new version of this tool that it's now integrated on the web with several new features that we will guide you through during this webinar. My name is Karin André, and I work as a senior research fellow and team lead for the consumption communities and the cities team here at SEI headquarters in Stockholm. And I will be moderating this webinar today. The Consumption Compass is a tool developed by SEI to illustrate and facilitate analysis of the climate footprints of consumption. And municipalities are the main target group of this tool. And it's based on several years of research at SEI on how to estimate and calculate emissions from consumption. But it's also based on research where we, together with municipalities in Sweden, have explored their challenges, needs, and also opportunities for addressing consumption-based emissions at the local level. And the question or the issue of how to mitigate climate impacts is maybe even more relevant today than ever, and we're increasingly seeing the consequences of climate change around the world. And we see that countries like Sweden that have quite high emissions have an important role to play and even a responsibility, along with municipalities in Sweden. And as you can see, here is an example of what the new version of the tool looks like. And it's a further development of the Excel-based tool that we launched in 2022. And we are very happy to see how well the first version of the tool was received. And we also can see that it has been picked up by various actors, not least municipalities that have been incorporating results from the tool in their strategic plans, but also used it for communication, etc. And we also want to take the opportunity to thank you all that has been in contact with us and has emailed us and been in dialogue with us about your questions, but also showed a lot of engagement, which has clearly helped us improve the tool. And as I said, today we're launching the new version of the tool, and we would also like to take the opportunity to invite you to continue dialogue, where we hope to have a continued exchange of ideas and questions so we can also continue further develop the tool. And this work is based on several colleagues' joint efforts together with our partners. We have a dedicated team here at SEI, mainly based in Stockholm, but also Tallinn and the US. We have our municipalities, Umeå and Kalmar, where we have two representatives presenting today, Mirella and Jennie from Umeå and Elvira from Kalmar. And we have also had a lot of input and important exchange with our external reference group throughout this work. And they are represented by the climate municipalities, the Stockholm County Administrative Board, the Swedish Environmental Protection Agency, Statistics Sweden, Viable Cities, WWF, and also an independent expert. And I should also thank Insight One, the company from which we have provided a lot of important data, Cloudberry, that had helped us integrate the tool on the web, and of course Formas, that made this project possible through their funding. And on the agenda today, after this introduction, I will hand over to Pelle Boberg, climate analyst at the Swedish EPA, who will set the consumption-based emissions a bit in perspective. Then I will hand over to Katarina, that will introduce you to the new version of the tool and present some of the results that we've seen from our analysis so far. Then Peter will go more into the method behind the tool, its data, and also some of results. And then we will hear from Derik, that will introduce the scenario function, which is also a new feature in this web-based tool. We are also happy to have the municipalities here today that will present some of their perspectives of working with the tool and based on their work with sustainable consumption at the local level. And towards the end, we will end up with some Q&A. And please add your questions in the chat, and we will pick them up throughout the webinar, but also towards the end. And if we don't have time to answer all questions, we will follow up after the event. So with that said, I would like to hand over to Pelle.
Yes, thank you, Karin. So very happy to be here. So my name is Pelle Boberg, and I am working at the climate department of the Swedish EPA. And as you mentioned, we are also in the external reference group of this project that we are very happy for. So next slide. I'm seeing the agenda.
Because that's my...
All right. Oh, sorry. Right. Okay. Yes. Okay, we're on track. Yes, consumption-based emissions, very important to keep track of. And as already was mentioned, of course, this is in the context and in the background of the urgent situation with our climate. We are already approaching the temperature limits set out by the Paris Agreement. In Sweden, we have one important framework for environmental work, which is our environmental quality objectives that are set out by our parliament. One of these 16 is the target on reduced climate impact, which directly connects to the Paris Agreement and says that Sweden is to do our part in limiting climate change to these temperature levels. This objective also has a number of milestone targets. These milestone targets are also part of Sweden's climate policy framework with our climate law. And these targets they consider the territorial emissions of Sweden, which of course partly overlap with the consumption emissions, although not fully, of course. We also, in this system of environmental objectives, have the generational goal, as it is called, which, among other things, says that Sweden is not supposed to solve our environmental problems by moving, for instance, emissions to other countries. So this generational goal gives further motivation for us to work with this consumption-based approach. We also have other frameworks, such as, of course, the Agenda 2030 goals, with goal number 12 on sustainable consumption and production, and so on. There are several other foundations here, but just to mention a little bit of the structure for us, for our work at the EPA and in Sweden with these issues. Right. So we will delve into the very local emissions today, but here we have the consumption-based emissions on the Sweden level. That have been produced since 2019, I think it is, by SCB, the Statistics Sweden, the statistical agency, with the data set going back to 2008, as you can see. This dataset has a background in a research project called PRINCE that had Swedish EPA funding. It's official Swedish statistics. It's run by the SCB, Statistics Sweden, but we also display these statistics at the EPA webpage. Right, so working with consumption-based emissions and this perspective is, of course, not something we just came up with here at the EPA or in this project, but something that is very evident in the research, such as the latest IPCC assessment, the very comprehensive assessment on mitigation that came out in 2022 with, for instance, a special chapter dedicated to the demand side measures and related. So there's clearly a huge potential in working with these approaches and potentials that we cannot afford to not take use of if we are to fulfill the Paris Agreement aims. About the same time as the IPCC report, we had all-party parliamentary environmental committee in Sweden that came out with a report from their inquiry on consumption-based perspectives with suggestions for consumption-based targets, strategies. The suggestions of the committee has not been decided on yet, but it is there to be considered. So what is going on right now? I put in here just as an example, we have Miljömålsrådet, which is a council of environmental agencies that are having a number of projects concerning sustainable consumption in sustainable foods and other projects. I can also mention there's a lot of research going on. The EPA is funding some relevant projects. We recently had one project coming out with a synthesis on sustainable food, for instance. Then the EPA is a small funder in research, but there are, of course, much larger enterprises as well, such as could be mentioned, for instance, the Mr. Sustainable Consumption Program that the EPA has also been involved in some parts in, which is quite large. I think might be one of the world's largest programs on sustainable consumption that is now running on its 8th and last year with many interesting results. Then in policy, we would clearly need to see much more action, but that said, there are a lot of things going on, not least on the EU level. We have the new eco-design and other legislations that are being introduced or are in the process. Yes, we are today looking at the local level, and that is very, very important what goes on in the municipalities, of course, on so many levels. For instance, on the global level at the EPA, we are part of the Swedish delegation to the UNFCCC climate negotiations, and we know that Sweden has a stronger voice and more credibility if we can show that there is strong climate action in the Swedish municipalities. And the other way around, of course. If we can move forward in the negotiations, that makes it easier to set policies on the global level, such as we saw recently, a policy decision in the shipping sector in the IMO, and in the EU level and in the national level, these policies that we need to really come forward all the way in the local climate transition. Thank you again for being here, and this is really a very important approach and a very important project as we see it from the EPA. So I'll hand over to you again.
Thank you, Pelle. And now I guess you're curious to hear more about the tool, so I will give the floor to Katarina Axelsson, our Senior Policy Fellow here at HQ in Stockholm, that has also been the project lead for the Consumption Compass project. So please, Katarina, go ahead.
Thank you, Karin. I'm very happy to be here with you today and present our work on the Consumption Compass. If I wanted to start off with this slide, it is against this development that we should understand the need to address our consumption-based emissions, something Pelle also pointed out in his presentation, that the global emission levels continue to increase. And as you can see from the quote here, this is also something that the IPCC states as something that has a great potential for reducing global emission levels, that we need to change our lifestyles and consumption patterns, and that well-developed economies such as Sweden have an important role to play in this as many people here consume beyond their basic needs, and where the mitigation potential therefore is larger in many less developed regions. So the consumption compass model then. This is a data-driven digital tool that estimates households' consumption-based emissions, so-called carbon footprint, for close to 110 different consumption categories. It presents estimates for households' carbon footprint at fine geographical scales for the whole of Sweden. And I want to emphasize that it is just estimates, and it's important to understand that at present it's not possible to provide household or provide estimates for household consumption by geographic area with any exact measures. However, we do think that the estimates will provide a good and solid basis for taking action against the results indicated by the tool. We have Swedish municipalities as the primary target group for this tool, which we believe that municipalities have a very important role and strong potential to promote more sustainable consumption patterns among Swedish households. We also see significant interest in our data from other groups, such as county administrative boards, academia, and interest organizations, something we are, of course, very pleased about. So what can we then learn from this tool? Well, it can help us identify the consumption categories that contribute the most to climate impact, so-called hotspots. It can show us emission trends over time, allowing us to track how emissions have changed. It shows us differences and similarities in household carbon footprints at different levels, national, county, municipal, and even sub-municipal scales. And we can also use the tool to compare the carbon footprint by different types of municipality groups. So how can the tool then support municipalities' work? Well, it can contribute to capacity building through the knowledge conveyed by the tool's data, something that we hope can strengthen municipalities' abilities to understand and act on consumption-based emissions. It can serve as support in municipality strategic work by informing more targeted and effective policy instruments and measures. It can be used to enable dialogue, engagement, and communication with residents and other stakeholders, as well as within the municipality organization. We also hope that it will help promote an understanding of the need for a just transition, as households' climate impact often varies significantly across the country for different areas. And we also hope it will strengthen acceptance and legitimacy for the measures that need to be introduced, something we believe can contribute to broader support for the transition through increased transparency and shared understanding. So what is new then with version 2? Well, for those of you familiar with version 1 of the tool, I can mention that there are a number of model changes compared to version 1. The most important ones are mentioned here on this slide. It's the energy model, more specifically the model for how we estimate the climate impact associated with households' use of district heating, where we in this version have taken in the local energy mix rather than the national average energy mix as we had in version 1. So we're very happy to have been able to apply a local energy mix in this version. And then for air travel, which is one of the most difficult consumption categories to calculate due to the lack of public data, we have updated or revised the model we have for air travel in this version, and we now use so-called mosaic data. And this data set applies a so-called trimmed average, which means that households with extreme flying habits have been excluded from the data set to avoid skewing like the average for different areas too much. So this results in significantly lower climate impact from air travel per area compared to version 1. So that is something to be aware about. And I should add that my colleague Peter will in a moment speak more about mosaic data, so I won't go into further detail about that here. So other news with version 2 is that we have then integrated the tool on the web. We now have a time series with 5 years, where the last year is forecasted emissions. And so that there is a lag in the data provided at the national level for Sweden's consumption-based emissions, which is provides an important foundation for our data. So we have forecasted emissions for 2023 based on emission factors for 2022. So we will focus on results for 2022 in this presentation. We also have a scenario function, which my colleague Derik will talk about later. And another important difference is that we now have moved over to so-called DESO areas instead of postcode areas. And what that is, I will describe next. And so DESO stands for Demographic Statistical Areas. And this is a statistical product developed by Statistics Sweden. There are nearly 6,000 DESO areas across Sweden. And if you compare that with postcodes, they are over 17,000. So postcodes about 3 times more than DESO areas. According to Statistics Sweden, DESOs are designed to be more stable over time, both in terms of population size and in their boundaries. They are not expected to change as much as postcodes have tended to do. DESOs also follow municipal boundaries better and take into account also spatial and natural barriers in a better way than postal codes, such as built-up areas, streets, waterways, railways, etc. So if we then move on to look at the results from the results we see from the consumption compass. We can start off with a sort of general picture showing the average consumption for Swedish households for 2022, which was 5.6 tons per person. And this excludes public consumption and private and public investments. And as you can see here, food was the category that causes the highest emissions, followed by private vehicle and air travel and housing related consumption, such as household equipment, furnishing, basic maintenance. In Sweden, we classify municipalities into 9 different municipality groups based on factors such as density and population size. When we compare emissions between different groups, or types of municipalities, we can see that the emissions per person are the highest in Sweden's largest cities, with an average of about 5.9 tons, and lowest in more rural municipalities with around 5.3 tons per person, a difference of about 600 kilos. And looking at the composition of the consumption in these groups, we see, for example, that group 1A1, the largest cities in Sweden, has somewhat higher food consumption, significantly higher air travel and clothing consumption, as well as considerably less car travel compared to many rural municipalities. If we instead want to analyze differences in emissions between so-called DSO areas and within a municipality, we can see that the differences are much larger and here you can see an example from Stockholm where the difference is over 4 tons, 4.2 to be exact, between the highest and the lowest DSO areas. And similar to previous chart, we can see clear differences in the composition of consumption between these different areas. So, and in the next slide, I show an example where you can also study like individual consumption categories, such as car travel that I show here. And here we can see that the average decrease since 2019 has been around 18% across all municipal groups. Maybe a note to say that this decline is likely to reverse and shift towards an increase in 2024, following a series of recent political decisions that have raised the share of biofuels in transport and removed bonuses for electric vehicles. But if we want to have a look at air travel, yes, thanks. A different picture emerges where we note the clear dip during the COVID pandemic. And we can then see also that different groups of municipalities have resumed air travel to varying degrees since then. And where we can note that households in major cities are now only about 9% below the level seen before COVID, while many rural municipalities, example C9 there, have not resumed air travel to the same or in the same extent. So with that, I wanted to demo the tool for you. I'll do a quick demonstration before handing over to my colleague Derik. So I will share my screen here and hope that works. You can see my slides or my screen, I hope. Shout out otherwise.
Yes.
Thank you. So this is what the tool looks like at its start page. It's set to start at 2022, and you can change the year here if you want. And you have different like windows here. You can pull these windows if you want to enlarge the map or any other area. And maybe I should also add that it can be a bit slow the first time you start the tool, but if you load a municipality several times, it has promised to become faster as the computer's cache memory is built up. So please be a bit patient in the beginning if you experience any slowness. And here to the left, you can, for instance, also change language, change color settings. You have a menu here where you, for instance, can go to the About page and read. Here you can find the method summary. We have a scientific article here presenting our partners, and also a section called Frequently Asked Questions with a lot of information here, which we hope will be useful to many users. And so in the Sweden view here, you can scroll down here to discover a number of different graphs and look at the distribution of emission by consumption category, and a full list of consumption categories, 109 to be exact, and you can sort here on emissions, or you can sort on all headings here actually. And in this first view, you also see a list of Sweden's counties' total emissions. And we have here top 5 municipalities with highest and lowest, top 5 DESO areas with highest and lowest. And throughout the tool, you will also find these different question marks. You can click to get some answers. And yes, maybe I should mention, if I didn't already, you can also, for many of these graphs, as well as the map, download if you want to work with the data in a different format. Then you can here, if you want, search then for different municipalities. We can take Uppsala here as an example. The map then zooms in on Uppsala, and you can see different areas of Uppsala here as well. Zoom in on that. And you also can see all the DESO areas of Uppsala listed here, and you can click on any one of these to get further details. And you can also take a closer look at different consumption categories here if you want to focus on food, for instance, and show that on the map. And then you can also compare with different areas here to get that into the graph. Sorry, I have a window hiding this box for me. Can't show that to you now, but yeah, so hoping that many will want to explore this, because there's really a wealth of data here. And yes, with that, I think I'll stop and hand over to Peter.
Thank you, Katarina. Just in between, we have a question from Antoine. I thought we can take it before handing over to Peter. Antoine says, what is the intention behind the use of geographic areas as a fundament for this compass? I thought maybe that could be good to answer before we move onto Peter's presentation.
Yes. Well, thank you. That's a great question. No, yes. So since a few years back, we only had access to like national average data for Sweden. But having worked close with many municipalities over the years, and just looking around your own neighborhood, I think everyone will understand that there are, in fact, large differences between households in different areas. I mean, it relates to your geographic region where you live, whether rural or urban. And it is, of course, also very closely connected to income levels, household situation, types of housing, etc. So with this tool, we wanted to provide a better analysis of differences and similarities in households' consumption patterns, and thereby also allow policymakers at different levels to better tailor policies and measures to respond to this sort of challenge or yes.
Yeah, great. Thank you, Katarina. And I think Peter will also present some results at geographical level. So I hand over to you, Peter, for your presentation. Thank you.
Yes, hello everyone. I'll just first ask, can you hear me okay?
Yes,
okay,
perfect.
That's good. There's no weird sounds like last time. So my name is Peter. I'm a researcher working at SEI Tallinn, so the Estonian office of SEI. And I worked primarily on developing the model and generating the results for the consumption compass version 2.0. So on the next slide, I'll just kind of briefly discuss in really general terms what we're talking about here when we talk about consumption-based emissions. I'm sure everyone is well aware of this, but just to make sure we're all on exactly the same page. When we talk about consumption-based emissions, we mean the assignment of emissions based on the final consumer of a product or service, rather than where the product or service is produced. So this means that if a product is purchased and consumed in Sweden, those emissions will be assigned to Swedish residents, even if most of the production of the product took place in a different country. And this has some similarities in terms of which emissions are included compared to kind of classic territorial emissions, but also some differences. So emissions that are caused, for instance, by Swedish residents when they fly abroad would be included in a consumption-based emissions inventory, whereas it wouldn't in a territorial-based inventory under most circumstances. And there are kind of a few different ways these inventories are compiled, but at the larger scales, they tend to use environmentally extended input-output analysis, or a hybrid of environmentally extended input-output analysis. So this is using kind of macroeconomic modeling together with emissions data to trace the emissions associated with the production of products and services through a supply chain. And this tends to not include kind of the direct emissions that occur through, for instance, the burning of fuel in a car. So mostly these emissions also are added on to give a full picture of the emissions associated with consumption and activities of residents or other kind of final consumers. So as we go to the next slide, we can talk in a bit more detail about the Swedish consumption-based emissions inventory. So as we heard before, this is kind of conducted by Statistics Sweden using the PRINCE model, which is an environmentally extended input-output model. And this classifies emissions on an annual basis across 107 different so-called KOICOP categories. KOICOP categories are just different categories of products, for instance. So different types of food, different types of transport, and things like that. And we use this along with a lot of spatially resolved data sets in order to assign a proportion of those national emissions to each deso area within Sweden. And this means that if we were to look at the total emissions or the emissions from a particular KOICOP category and sum them up across all of these desos, the values we would get would equal the national emissions as detailed by SCB. In general, we can see from the graph here that Swedish consumption-based emissions have dropped from around 7 to around 5 or 6 tons between the years 2008 to 2022. And this has been the case, there's been a drop, or there was a drop, let's say, until 2020, and then there's been somewhat of a rebound after COVID. Moving to the next slide, I'll also kind of talk briefly now about the main kind of data set that we use in order to make this assignment of emissions at the deso level. And this is something called lifestyle segmentation, or more specifically the mosaic classification. This is a classification of lifestyles that was originally developed in the 1990s by a company called Experian. and is carried out in the Nordic countries by a company called Insight One, who we've already heard about. And what they do is they classify the population of Sweden into 44 different lifestyle groups, and 14 kind of broader or larger groups that those 44 sit within. And within each deso, there is a distribution of these different lifestyles. So there is a percentage of people that fit into each one of these lifestyle groups for every deso. And this distribution of lifestyles across each deso and across all desos in Sweden is the basis that we use for understanding the emission profiles of different desos. Alongside this, we have a lot of parallel data on consumption provided by Insight One, alongside other data sources. So if I was to go into this in a bit more detail on the next slide, we can see other sorts of data that we use. So we use a lot of other data from Statistics Sweden, particularly energy use data and other data that is kind of resolved to the deso level. We also use household budget surveys, or HBSs, which are surveys of household expenditure on a wide range of products that is conducted periodically by most countries in the world, principally to understand inflation, but these surveys are also used very widely in consumption-based emissions accounting. We also have different sorts of travel data sets. We get a lot of these from Insight One as well, but also from other sources. Another interesting data set we use is the Climate Calculator, which is another SEI tool. It's a self-reported consumption-based calculator for Sweden, and we use this at the moment only to understand the distribution of diets between municipalities. So how many people, or what proportion of people in a particular municipality eat a particular diet, and that's important for our food-based emissions. And the key kind of methodological principle we use is to downscale the emissions to break down the national total. And that means we don't consider in absolute terms how much people in a particular deso use on a particular product or consume on a particular product. Or we don't worry about it too much compared to how much we worry about the relative share of that consumption. So how much a particular deso consumes compared to every other deso in Sweden. That's the key kind of step we take in order to downscale the data. And this means that we can use a wide range of consumption proxies. So we're not just limited to expenditure. We can also use things like average number of trips taken or house size as proxies of consumption. We don't just need to look at expenditure data. And the final thing to say is, as I think was also mentioned, we're kind of only considering household consumption here. So in Sweden, this is about 60% of total consumption-based emissions. It's usually somewhere between 50 or 70% of total consumption-based emissions. So there are other forms of consumption that we don't downscale. We just assign equally to all desos in Sweden. If we go to the next slide, I can give a bit more detail in kind of how the model works. So this kind of diagram describes the different steps we take in order to downscale the data. The green boxes are kind of questions we ask of the different data or the different kind of categories that we have. So starting from the national emissions per Koikop category, we first ask if we have consumption data or expenditure data by mosaic group. And if we do have that, then we can essentially downscale it directly to the deso level because we have a distribution of the different lifestyle groups per deso. And if we have the average expenditure of each lifestyle group on a particular category, then it's straightforward to downscale that to the deso level. If we don't have that direct consumption expenditure data for a particular category, then we next ask, is the data a food category? Because if it is, then we have overall average grocery expenditure per deso, and we also have the distribution of diets, which we get from this climate calculator data. So we can therefore downscale total emissions to the municipal level first using this distribution of diets, and then we can then downscale it to the deso level using this average expenditure on groceries. There are also some categories that don't meet either of these requirements, and then we use household budget survey data. So if we can find that data for a particular consumption category within the household budget survey, we can then downscale it to what's called the municipal group. So as Katarina said, this links a lot with how urban or rural the municipality is. And then we can downscale it from the municipal group level to the DESO level based on income. And there are also, I think, 3 different consumption categories that we can't downscale based on any of these 3 principles. And therefore, for those, we just downscale from the national emissions to the local level based only on income. And once we've done that, we get to what we call the intermediate local emissions. And on the next slide, we can see that there are a couple of different cases where we replace that data because we actually have more accurate data to account for a couple of sectors. So these are energy and transport. So for energy, we have from SCB data on consumption of households at the municipal level and for different types of energy, so electricity, district heating, gas, etc. And then we can downscale from that municipal level to the DESO level. We do that first by using a data set called Boberg, which we use only to understand which heating sources or energy sources are available in which DESO. So essentially where district heating is or where gas heating is. And then from that point on, we make the assumption that the energy use per square meter is constant within a municipality for a given type of energy, and we can then downscale based on total floor areas of each DESO. For transport, we first ask is the category a private transport category? So essentially, is it to do with private vehicles? And if so, we have direct data from Insight One, which comes from vehicle inspection data on the distances traveled and the emissions associated with that of every DESO in Sweden, and we can therefore downscale the data based on that. For other transport categories, we have survey data from Insight One, and we can use that as the basis for downscaling. For all other sectors, we don't change the results that we previously calculated. It's just for energy and transport that we make these modifications. And there are also the sectors where we tend to have to add on direct emissions. And in the case of air travel, we also add on the emissions associated with high altitude flying. If we go to the next slide, we can see kind of the distribution of emissions across the different sources. So the percentages here refer to the national emissions. So what percentage of national emissions are downscaled based on a particular method. So we can see that 80% of our data is downscaled based on Mosaic and Insight One data, whereas 13% are downscaled based on household budget survey data, and 7% are downscaled based on energy consumption data. This 7% from energy consumption is a feature, I think, of Sweden because for instance, electricity is quite decarbonized already. I think if we were to instead look at Estonia, we would find the share of emissions coming from energy consumption would be quite a lot higher. We can also see that the share of emissions coming directly from income is 0.2%. If we go to the next slide, we can sort of see how our results look across the years. So as we heard before, emissions in 2019 were around 6 tons on average. And this is represented by these graphs here, which are called box plots. So the box in the center for every year describes where 50%, the middle 50% of values sit. And the upper and lower lines describe the limits above which we consider data to be outliers. So we can see that we, in general, have more outliers at the DESO and indeed municipal level that are upper outliers, that are outliers because they have higher emissions rather than outliers because they have lower emissions. But you can also see this kind of expected big drop between 2019 and 2020, and thereafter a slow kind of rise of emissions. At the DESO level, we even see that the highest DESO in 2023 has higher emissions than the highest DESO in 2019. If we go to the next slide, we can also see how these emissions are distributed across different sectors, again using box plots. So one thing that is obvious from here is the number of outliers to do with heating. We have, in general, the median value, which is represented by the middle line in each box. The median value for heating is actually rather low at the deco level. It's maybe 200 or 300 kilograms per capita. But we also have a lot of decos with much higher emissions. With flights, we also have some decos that have high emissions. But we also see in the case of flights and indeed private vehicles that the distribution is actually rather symmetric. If we go to the next slide, we can also see how the emissions data between different sectors is correlated with one another. So I'll kind of briefly describe this data. It's describing what's called the correlation coefficient between different sectors and between total emissions. So this kind of describes how linked the different emissions are. So if the correlation coefficient is 1, then this means the data is perfectly positively correlated. And this means as one data set increases, the other one will increase in line with that. If the points are very green, then they would be perfectly negatively correlated. And this would mean that as one data series increased, the other one would decrease as that one increased. I think the things I want to point to here are this middle block box to do with transport. So we can see that private vehicles are strongly negatively correlated with both public transport and air travel. So as private vehicle emissions increase, we generally see public transport emissions decrease and air travel emissions decrease. And the other thing I want to highlight is this row at the very bottom, which is to do with total emissions. So we can see that most things are somewhat correlated with total emissions when we look at all of the data together. But private vehicles, when we consider all of the data together, is not particularly correlated with total emissions, and neither is electricity. I just add that this is when we look at all the data together, and if we were to look at subsets, then these relationships might be somewhat different. We can also, on the next slide, look to see how these relationships change over time. So we can see that flight emissions, which were correlated with total emissions, lost this correlation during COVID. So as flight emissions kind of collapsed during COVID, the relationship between flight emissions and total emissions disappeared. We can also see that personal vehicle emissions consistently have not shown any correlation with total emissions when we consider all of the data together, with the possible exception of 2021. We can see that food and heating emissions are moderately correlated with total emissions, and spending or emissions on restaurants and hotels is the most strongly correlated with total emissions across our data set and across all years. If we go to the next slide, we can also look at how income is correlated with emissions. And I give the caveat that this is data that has been only briefly analysed, and I would not want to overanalyze these conclusions at the moment, but we do indeed see a correlation between total emissions and income. And we see that the value of this correlation coefficient, which kind of describes the link between income and emissions or total emissions, appears to be increasing over the years 2019 to 2023. So there is some evidence that this link between emissions and income might be strengthening over time, but more detailed analysis would be needed to kind of reach kind of more rigorous conclusions on that. If we go to the next slide, we can also see how emissions look if we are to look at the different lifestyle groups. So as with the geographical assignments, we see this big drop between 2019 and 2020, and then a slow rise after that back to values that are not too dissimilar in 2023. The table here describes the 5 highest and 5 lowest lifestyles. It's interesting for me that the lifestyle which we find has the highest emissions in 2022 is not the one that has the highest income. So the highest income group is only in third position, although the differences between the top 3 or 4 are rather minor. Amongst the bottom kind of decos are typically ones that are not associated with urban areas. Like for instance, N44 is a rural group, and they're also the groups that have lower income. And I think that's the last slide from me.
Thanks a lot, Peter, for this presentation. And we saw some questions in the chat before, but now they somehow disappeared. If you still want your question answered, please put it again in the chat and we will capture it later on in this webinar. With that said, I will hand over to our colleague in the US, Derik. It's early morning for you, but I hope you are ready to present to us the scenario function, which is a new feature of the tool. So please, Derik, go ahead.
Yes, thank you. I've had my coffee now, so I think I'm ready to present. Great, thank you. So yes, the scenario function is a new function that we've added to the tool this time around. And the idea with this element of the consumption compass is to allow municipalities and any users really to essentially play around with different scenarios for how consumption-based emissions, greenhouse gas emissions, could be reduced through various changes in household consumption. So it allows you to explore how shifts in consumption would affect emissions over time, with the idea of illustrating how household consumption shifts could support global efforts to reduce greenhouse gas emissions. So, of course, reducing consumption, unless you reduce it entirely, is not going to completely eliminate emissions. But there are ways in which changes in consumption could help get us to lower emissions and move us towards global goals for lowering greenhouse gas emissions as targeted under the Paris Agreement, for example. So this scenario function allows users to look at 10 different options for reducing or shifting consumption in ways that would reduce emissions. So it's really a subset of the total emissions footprint of different households in Sweden. Just looking at these 10 categories, I think as Katarina mentioned earlier, there's 109 different categories of consumption in the consumption-based emissions inventory in the database. So these actions really target a subset, a smaller subset of those 109. But they're focused on the kinds of actions that various studies suggest could have the greatest impact on emissions, or over which municipalities may have some relatively direct influence. So working with residents of municipalities, these are things that households could perhaps most easily do to reduce emissions. So we look at options in 4 different categories: transport, so things like reducing car travel or just the number of cars that households own; shifting to electric cars, reducing air travel. There's an option for reducing home energy consumption. We look at the food sector. So food waste, reducing food waste is an option, as well as shifting diets to lower emission diets. And then finally, some high emissions intensity, I guess you could say, categories of goods. So reducing clothing consumption and furniture and furnishings consumption. So all the reductions are calculated with respect to a reference scenario, and it's a fixed consumption reference scenario. And if we go to the next slide, I can explain what that means. So here you can see a kind of chart showing how the various options contribute to lowering emissions over time relative to that top line, which is a projection of what household emissions would look like over time if essentially nothing changed with respect to the 2022 base year emissions inventory, but population within the municipality were to grow over time in line with projections. So it's a fixed consumption. That is, we assume household spending and the emission footprint of the consumption of households doesn't change, but population grows over time. And so the various options that you can configure here suggest how emissions could be reduced if you were to, for example, reduce car travel. In this case, you can see on the right-hand side there by 75%, and getting to that target by 2050. So you can configure the percent change or reduction in consumption, the year in which this change starts, and the year in which that total reduction is achieved. And you can do this for each of these several options. So car travel, vehicle ownership, shifting to electric vehicles, as you can see on the right-hand side there. And then you can see there's a dashed line at the bottom, which is basically showing a pathway to 600 kilograms of CO2 equivalent per household, or per capita, I should say, which is indicative of where emissions would need to get to in 2050 to align with keeping global warming well below 2 degrees, so that Paris Agreement targets. And you can see we don't quite get there, even with configuring some fairly aggressive assumptions about shifts in household emissions. But with this, again, this is just a subset of the total emissions that are being targeted here. And what this shows is how changes in household consumption could contribute to getting to that level of emission reductions over time. So you can play around with different scenarios. One key caveat, I guess you could say, with shifts in household consumption is that they can sometimes have what we call rebound effects. So if we go to the next slide. So this is a different chart. This is showing the level of emission reductions in 2050. So this is just a single year. It's kind of a slice in a single year of the emission reductions that would be achieved through all these changes in household consumption. On the left-hand side, you can see the contribution of various measures to reducing emissions. And that's showing essentially the direct emission reductions that would occur from these changes in household consumption. That middle column there shows you the end result. But what happens oftentimes is if you reduce consumption, that ends up saving money, right? You're not spending as much money on a particular category of consumption, and the money you save then can be spent on other goods and services. And those other goods and services will have some emissions associated with them, and that's what we refer to as a rebound. So there may be some reduction in direct emissions, but then an indirect increase in emissions as those savings are spent elsewhere. And those columns to the right-hand side in red show you the rebound emissions, the calculated rebound emissions associated with these different measures for shifting and reducing consumption. So that then gives an illustration of what the net emission reductions would look like, taking into account these shifts in consumption, which is an important consideration if you're looking at what an optimal strategy might be. Again, you can play around with the different the levers here and the assumptions for changes like meat and dairy consumption, you can configure what that consumption is shifted to in terms of other food categories, and what that shift looks like will determine the net level of emission reductions that are achieved from these different changes. So next slide. So there are some things to keep in mind with this tool. One is it's very much a kind of sketch tool at this point. It's stylized in the sense that we're calculating emission reductions against this fixed consumption reference scenario. In reality, of course, emissions consumption habits are likely to change over time. The relative prices of goods and services are likely to change. And we can expect reductions in the carbon footprint of consumption over time, even without these shifts in consumption due to climate change policies in Sweden and in the rest of the world that will tend to lower the emissions per unit of goods and services consumed. And those variables are not reflected here. But what this scenario function does allow you to do is explore how shifts in consumption can contribute to these other efforts that might get us to global net zero by 2050. So the 10 measures here don't get us to zero emissions, but they, again, the idea here is to indicate, what we sometimes call a behavioral wedge. That is how changes in consumption behavior can help get us towards the goals we want to see. So it's illustrative, but it's an interesting way to build off of the inventory data we have and allow municipalities and households to understand the contributions that different categories of consumption and shifts in those categories of consumption could contribute to global goals. And I will leave it there, and happy to answer any questions on any of this if folks have questions. Thank you.
Thanks a lot, Derik. I saw there was a question in the chat, but now it disappeared. I don't know what happened. Do you have it, Ylva, or? Yeah, so wait a second and we will share the question with you, Derik, because it was a specific question regarding the scenario function.
So, hello. So there were two questions. Is the tool able to show consumption per socio-cultural group, income level, which would most likely show even higher inequalities than between the DESO areas? That was the first one. The second one, what SSP scenario is used for the rest of the world? So maybe, Derik, you can take that one, if you can answer that one.
Yeah, excuse me, the quick answer on the second question is we do not make assumptions about the emissions footprint in the rest of the world in this version of the tool. So instead, the emission reductions are calculated against a fairly simple projection of household emissions over time changing only according to population growth. So the emissions intensities of consumption are fixed at 2022 levels, and the reductions are against those levels. So in future versions of the tool, we may build in some more scenarios related to the reference case that might build in different SSPs, for example, showing what the contribution of efforts in Sweden and the rest of the world might be to reducing household consumption. But this is just looking at a fixed reference case scenario and how changes in household consumption could reduce emissions below that.
Thank you, Derik. Katarina, will you continue to give us a summary of what we've heard so far.
Yes, thank you. And if you, Ulysses, can you share the presentation again? Yes. So I just wanted to really quickly sum up what we have talked about and with regards to what we have found in the data in the Consumption Compass tool. Yes, so we have, as we mentioned, noticed small differences in average climate footprint between municipalities, but larger differences within municipalities at the so-called decile levels. We note that the largest cities have somewhat higher average climate footprints than other municipality groups. We noted that the consumption levels dropped clearly during COVID, but has since then recovered to a large extent. Food, car travel, and flights are the consumption categories with the highest average emissions. And we also note that climate footprints are closely linked to income, but that other factors also matter, such as location, transport needs, housing types, family size, etc. So strengthening the climate transition it's important to bring local perspectives in order to strengthen the climate transition. Standard national policies may not fit all contexts as they often overlook local conditions and household needs. Local data, we want to suggest, is crucial for adapting mitigation efforts to specific contexts, supporting strategies and communication. And Swedish municipalities show a clear sort of growing interest in locally tailored solution, highlighting their key role in enabling a fair transition, which is also, facilitated by their closeness to households' everyday life. And we think that by working with more local data, we think that this approach can work to enhance public acceptance and help accelerate the transition to sustainable solutions. And by that, or in that way, reflecting on both climate footprints and citizen well-being. So with that, I hand over back to you, Karin.
Thank you, Katarina. So now it's time for our two municipalities, Umeå and Kalmar, to present their perspectives on their work with sustainable consumption at the local level, but also their experiences of using the Consumption Compass tool. So I give the floor to Mirella Persson and Jennie Vennberg in Umeå first, and then Kalmar will present.
Thank you. Yes, I am Jennie Vennberg, and with me here today I also have Mirella.
Hello.
And we come from Umeå Municipality. It's a city in the northern of Sweden with just over 130,000 inhabitants. And we've been a reference municipality since the start with the first version of the tool. And we are really grateful to be here today and share with you our experiences and also hopes with this tool. But first, I would like to share our thoughts on the issue of addressing consumption-based emissions. Yes, we have been addressing the consumption-based emissions for quite a long time, and our target in Umeå is to reduce the emissions from around 9 tons today, including public consumption and investments, to 2 tons in 2040 and 1 ton per person and year by 2050. And by measuring the climate footprint of consumption we believe that other challenges are made visible than those that are visible when we measure the territorial emissions. And one example is food. We have very little food production within Umeå municipality. So when we measure territorial emissions, it almost looks like we have no emissions at all. But all residents of Umeå, of course, have to eat sometime. And when we measure from a consumption perspective, it becomes clear that we also have to work with food to reduce the emissions we cause, even if they occur elsewhere or in Sweden or the rest of the world. But a challenge for us when we work with these issues is that it's not really perceived as a municipality's mission. People feel that we are interfering in their private lives. And we believe that this is maybe due to a misunderstanding that the climate impact of consumption is often equated with lifestyle changes and influencing behaviors. I mean, we've been talking about these things today, but we want to get away from this way of thinking. We mean that regardless of whether we work with territorial emissions or consumption-based emissions, we want to be able to use the entire toolbox. And this, I mean, it includes trying to persuade people to change their consumption habits. There are, for example, also about working for new laws and regulations on a national levels, or developing new public services or new business models that in turn can lead to change consumption behaviors. So how can this new, improved, user-friendly tool support our work? Well, we have many hopes for this version of the consumption compass. Perhaps the most obvious is that it would be a very important basis for decisions and follow-up. With this tool, we can report on how we are doing in relation to our targets, and also show our decision makers in which areas we need to focus on our efforts. The fact that there is a delay in the statistics is, of course, a challenge. But however, we still be able to show a trend over time, and that's very important. We also want to use the consumption compass to identify areas and neighborhoods that stand out in one way or another. It can be like to find areas where emissions are unusually low and investigate what works out in that area, learn from the good examples, and also give the residents in that area some recognition. It can also involve finding areas where we see that emissions are high and addressing that. But then it's very important that we include those who live there. And I was thinking that Mirella should talk a little more about that.
Yes, thank you, Jennie. Like Jennie started, we can see that we believe that this is an opportunity to understand our citizens and their needs and challenges in different and also a deeper way. We believe that we, of course, need to have statistics and so on, but we also need to focus more about the dialogue with our citizens. We believe that this tool allows us to help us to identify which actions could work and which actors we need to partner with in a specific area to make a difference. And actors can be like residents or businesses or municipal companies and so on. We also believe that this is an opportunity to create engagement in a neighborhood. This creates conditions for us to work locally, which we believe is necessary to cultivate this stronger engagement. Getting to know your neighbor can be one of those things, but also we want to understand like how we can create the feeling that we're doing this together, not something that you only need to solve alone. So yeah. And we also have like a message to other municipalities if you are listening. And we believe that if you want to use the tool, it's great, but you also need to anchor internally and just talk with your colleagues that are supposed to use this tool so you know how to use the tool, because we believe that it will be a much smoother way if you do it that way. So with that, thank you for listening, and I will leave over. Thank you.
Thanks a lot, Jennie and Mirella. And I will be very brief and welcome Elvira to present from Kalmar.
Thank you very much. I'm here. I'm Elvira Laneborg. I'm a sustainability strategist from the Municipality of Kalmar. And one of the reasons why we entered this project, it was also in 2019, is that it has become more and more clear that the consumption has a great contribution to climate impact, and it's more and more relevant that we look at the personal and local contribution to global impacts. We speak about climate justice, World Overshoot Day comes earlier and earlier each year, and it's clear that we are living way beyond the budget for the planet, and we need to do something about it. We need to go from those 9 tons per person down to 1 ton by 2050 in order to reach the Paris Agreement. So that the gap between where we are and where we ought to be, it leads to engagement, but also we need to focus on that it is possible and show how we can do this, and we need data to do this also. I have worked with a colleague from working with social sustainability, Stina Nordström, and together we have explored this tool together. Let's move on and just show you a short picture of the city of Kalmar, situated in the very southeast of Sweden. We have now 72,000 inhabitants, and our city and municipality is growing quite fast. By 10 years, it's estimated to have another 10,000 people, and we need to grow in a sustainable way, and attacking and the consumption-based emissions must be part of this growth. So let's go on to why we like this tool, and I've added some bullet points here. The first one is that it gives us a very local view of the consumption-based emissions, but it also gives good opportunities to compare to other geographical areas. And it has this consumption-based data is a massive data set, and it can be difficult to grasp it. But the tool helps us to summarize and to give the overview of all this data. But still, it also can give us, if we want to dig into the details with those 110 something categories, we can do that. So it's very good for both the whole picture and for the details. We also like the flexibility of the tool. We can see that it attracts very different professions at the municipality. So of course, those working with spatial planning, but also infrastructure and mobility issues, but also statisticians, people who work with social sustainability, also maybe digitalization. So it's a variety, and you could be interested in many different ways when you see this tool. We also see that it's flexible, that you can look at the current situation, you can look at the history, and you can look at the future. That's also very good for us. And we can see that it has very differences between different areas within the municipality, and we need to be, as also has been said here before, we need to be more focused on those local varieties in order to get the correct measures done and impact further on. Maybe it's not so clever to offer a carpool in an area where many people are likely not to have a driving license, for example. Maybe better to offer something with bikes. And for us, this tool has also been a way to merge the social and the ecological sustainability. It helps us to bring out this dialogue between different expertise within the municipality. And I wanted to show you also some examples of how we have used the tool. So moving on to the next slide here, the first one that we have is a couple of years ago, where we had a sustainability conference, and we used data from the compass here to illustrate 3 different lifestyles. So we brought to the stage to make a sort of improvised play. One person representing a rural lifestyle, another one representing a city apartment lifestyle, and a third one representing luxurious villa lifestyle. And they all received personal coaching on housing, on food, on transport and shopping. And this was very clear and good discussions, and it led both to laughter and to insights. So a good way to use the data. The second example is, as we have had an area within the city that we want to try out to get climate neutral. And we use data from the consumption compass as base for the dialogue, more or less. This area has some social, economical challenges, and we need to find out what are the best measures to reduce emissions. A third example is that we have used it in our public annual environmental report, and you can see a picture from that here, and also in a podcast that we have. So in different ways of addressing the public. Yes. And the last example is the most recent one, where we are in an ongoing work to bring out a new strategy and action plan for becoming a climate neutral and circular society. And we use data in this work as well from the tool here. And last, I want to address some of the thoughts going further on and what's ahead of us. We would like to know a little bit more about the reasons of the differences between different areas within the municipality. We would like to do a campaign for the inhabitants. We would like to use the data more in dialogue with citizens. And we think, again, has been said also, that the very local data could be more, people get more engaged in that, and it brings out curiosity, that you want to know what happens at your neighborhood and the next neighborhood. It's more relevant for most people than global data. If we can have one wish also, we would like to add a gender perspective in next stage, because we also see that there are differences in how men and women act and their climate impact, of course. And then, of course, we want to use the tool even more within our municipality, but also recommend it to colleagues around the country and other actors that we cooperate with. So by that, thank you for listening to me. And if you have any further questions, this is how you can contact us. Thank you.
Thanks a lot, Elvira, and thank you also, Mirella and Jennie, for your presentations. It was very interesting to hear more about your work and also inspiring to hear your thoughts about future work. Now it's time for questions, and we would like to start off with 2 questions, and I hand over to Ylva here that will facilitate this section.
Yes, so there is a question to Peter. Is the tool able to show consumption per socio-cultural groups or income levels? You ran through this briefly in your presentation, but maybe you can elaborate a bit on that.
So the kind of the functional unit of the tool is the deso. So that means in terms of breaking things down below the deso, it's quite difficult. And a consequence of that is that we have to assume that everyone within a single deso, no matter their income or their lifestyle group, consumes then in the same way. So that presents challenges in terms of presenting the data in terms of lifestyle group, which we get around by just doing a weighted average essentially of the population of each lifestyle group in each deso. And that means that we can calculate the results per lifestyle group, but it's an estimate because we have to make this assumption for a lot of different consumption categories that everyone within a deso consumes in the same way, even if they belong to a different lifestyle group. I think in terms of income, it's more clear to be able to present the data. We can do that because we have separate data on the average income of each deso. Again, with the caveat that we can't break things down below the deso, so we can't say anything about how things are distributed within a single deso. I would make the additional slight caveat that for some categories we use deso, we use income to both estimate the footprint, and then if we were to also use it as an explanatory variable, then we have to be a bit careful because then our conclusion wouldn't be particularly valid. So it's definitely true that we can present things, particularly in terms of income, but we're only kind of just starting on this journey, I would say, to be able to reach kind of more rigorous conclusions.
Thank you very much. So we have the second question goes to Katarina. What are the key challenges in using the tool to monitor the effects over time of a municipal climate strategy with consumption-based policies, for example?
Yes, thank you for that question. Yeah, well, one challenge can be that there is a slight lag in the data from the national level. There is a time lag of 2 to 3 years. So you have to be a bit patient to see the full effect of any measures you take at the local level. But then there is also a difference relating to the different data sets that we have. So for instance, for car travel, we think we have very good data, which is updated on an annual basis. I think we might already have access to data for 2023 for sure, but maybe even for 2024. So for car travel, we would be able to provide, like if a municipality turned to electric vehicles 100% 1 year, we would see the effect of that. And similar with regards to the energy consumption, or there is a time lag in that data as well. Yeah, but then, so the Mosaic data that we have access to, they undertake annual surveys. They collect data from different data sources on an annual basis. And there is only about 6 months time lag in that data set, but we will then still be able, or we will need to sort of await emission factors from the national level. But yeah, and then I also wanted to say that then as the mosaic lifestyle groups work is that we have detailed data with estimates of how the 44 different lifestyles group consume. So if there is a group, say group A1, they are spread across the whole of Sweden. So everyone belonging to group 1, if they change their consumption pattern in the same way, that would show pretty much immediate effect in the data. But if one group in southern part of Sweden changes differently than another group in another part of, or than group 1, sorry, this got a bit complicated now, baby, but yeah, but by time it will be sort of possible to follow sort of changes in consumption patterns. If one group changes their consumption habits a lot, that will eventually also be reflected in the description of the groups, and one group might move to another group, or parts of the population will move between the groups. But so unfortunately we will not be able to sort of follow changes in consumption behaviors as quickly as we would want. But yeah, and then for different data sets, it's quicker than for others. I hope that was sufficiently clear.
Thank you very much, Katarina. And of course, you are welcome to explore the tool in the link in the chat function. And I'll leave over to Karin to conclude. Thank you.
Thank you, Ylva. So now we're reaching the end of this webinar, and would like to thank you all who participate today, both online and our speakers, and also thank you for your questions. And now the work continues for us, and I hope you are also excited to try out the tool yourself. And as we mentioned, we have a new project that will actually start already now to continue the tool development with a focus on integrating socio-demographic data into the tool. So we will be busy continue working with the consumption compass. And before we wrap up, I would also urge you to contact us via this email, konsumtionskompassen@sei.org. So don't hesitate if you have any technical questions or any other ideas or suggestions. With that said, I would like to thank you for today, and also thank you Formas for you funding this project. Bye everyone.